In the late 18th century, James Watt perfected the steam engine. It started a revolution which became known as the Industrial Revolution. After the Industrial Revolution, humanity has thrived like never before. Our population has boomed and our technological capabilities multiplied. We have found ways to manipulate nature into giving us computers, cars, planes, and even the possibility to go to space. We eat better than ever, we live longer than ever, and we are richer than ever. While all of these are good things, will there ever be a point when it is enough for humanity? Because all the good things, all the riches, they come at a price. A price most of us haven't had to pay yet. But the time of payment is getting near. By now we should all be aware of the existence and dangers of climate change. In short, the greenhouse gases we produce trap more and more sunlight in the Earth's atmosphere, and little by little it causes our planet to warm up. That in turn causes drought, more and bigger storms, unpredictable weather, food insecurity, heat stress, and a plethora of other issues. While global warming is the big bad wolf in media, there are also other significant, a lot less publicized issues that our excessive lifestyles cause. In 2009, a team of scientists led by Johan Rockström identified 9 planetary boundaries, out of which climate change is only one. The other 8 are ocean acidification, stratospheric ozone depletion, the nitrogen and phosphorus cycles of the world, global freshwater use, land use, the loss of biosphere integrity, chemical pollution, and air pollution. The planetary boundaries represent points where Earth systems start functioning unpredictably compared to what we consider normal. Since we are all just passengers on this pale blue dot, the unpredictability of that dot would have tremendous impact on all life on Earth. While the exact points where the boundaries are still debated, it is generally accepted that these boundaries do exist, and it is probable that as of 2023 we have already crossed 6 of them. First, let's get into the good news. The depletion of the ozone layer became a growing issue in the 1970s. The ozone layer is a layer of oxygen atoms in the upper atmosphere that are organized into groups of 3, unlike the regular 2 atoms in normal oxygen. The layer protects the Earth from 97 to 99% of the sun's ultraviolet rays. Of the different types of ultraviolet radiation, UVC is the most dangerous to all life. Luckily, it is all absorbed by the ozone and the regular oxygen in the upper atmosphere. UVB is less harmful but still can cause sunburn, skin cancer, and cataracts. UVB is also mostly filtered out. UVA, as the least harmful, is mostly able to pass through. The cause for ozone depletion is entirely human, and especially in the chemicals that we made. CFCs in particular, a group of chemicals invented in the 1930s which became a roaring success in air conditioning, cooling, and aerosol propellants. At the time it wasn't known that they are in fact ozone-depleting chemicals. Their longevity and ease of circulation to the upper atmosphere were the cause of the problems. They break down ozone molecules and they can stay in the atmosphere for a century, so each CFC molecule can destroy up to 100,000 ozone molecules during its stay in the upper atmosphere. Luckily, ozone depletion was recognized as the problem it was, and CFCs were banned in 1989. Unlike fossil fuels, they were easy to replace both economically and politically. The CFC molecules will still float around there destroying ozone for decades, but it is believed that the ozone layer will recover in the 2070s to pre-1980 levels. Another boundary we haven't yet crossed is ocean acidification. It's well known and quite logical that global warming also causes ocean warming, as oceans are basically the heat storage of the globe. But the same catalyst, carbon dioxide that causes climate change, also causes ocean acidification. The ocean stores most of the heat that's received by the Earth from the sun, but it is also a chemical storage. And when the atmosphere's carbon dioxide levels start rising, the oceans absorb the carbon dioxide from the air. When this carbon dioxide meets water, it produces carbonic acid, which then splits into a bicarbonate ion and a hydrogen ion. This free hydrogen ion then increases the acidity of the ocean. While the oceans of the world aren't acidic, in fact they are alkaline, their acidicity is increasing, and that is causing trouble for the living things which have adapted to the current pH, especially crustaceans, mollusks and corals that need to build shells and other things out of calcium carbonate. In a more acidic environment, this just isn't possible. But it's not just the builders of the oceans that are in trouble. The decreased pH levels pose a number of problems throughout the food web, making it possible that the ocean world's ability to uphold life might rapidly decline. These problems include changes in acoustic properties that cause issues for echolocation and other communication. In fact, most fish in the sea communicate by sound. The acidity is also harmful to fish larvae, and it can increase the amount of poisonous algae blooms. Ocean acidification also weakens its ability to stash away carbon from the atmosphere, which in turn creates a positive feedback loop for climate change. Not too positive for us though. The third and final of the planetary boundaries we haven't yet crossed is air pollution, or technically atmospheric aerosol loading. An aerosol is a suspension of fine solid particles or liquid droplets in air or another gas. This is the only one of the planetary boundaries for which the scientists haven't yet been able to figure out where the actual boundary is, but they think it hasn't been exceeded yet. The most radical of the effects that atmospheric aerosols have is their ability to scatter solar radiation, thus cooling the Earth. It is possible that the northern hemisphere hasn't been warming up as much as the southern one because of the aerosols we have sprayed into the atmosphere. The southern hemisphere is mostly made out of ocean, so the aerosols there aren't nearly as spread out. The aerosols also affect cloud formation and convection in the atmosphere. Other more imminent effects on humans are breathing and lung problems, heart disease, strokes, and other health issues. The ozone layer, ocean acidification, and atmospheric aerosol loading are still within the safe boundaries. Although, unlike the ozone layer, ocean acidification and atmospheric aerosol are going the wrong direction. But what about the rest, the ones we have already passed? As mentioned before, climate change is the most well known out of them, but there are 5 more. Beside climate change, the first boundary we have already crossed is land use. Comparatively, it's straightforward and easy to understand. Humans use a lot of land. We turn forests, marshes and deserts into fields, cities and roads. We have been working the land to our liking for millennia, but we haven't always been very considerate of how the change affects other life and even ourselves through a roundabout way. Desertification, deforestation, soil erosion and degradation are all major problems with effects ranging from yet again amplifying climate change to loss of crops and farmland and displacing wildlife. Over half the world's habitable land is already taken up by agriculture, and more of the world's forests are being cut down to increase that share. Even though the Industrial Revolution was the start point for the race to a lot of the planetary boundaries, deforestation is older than that. A lot of deforestation happened before the age of steam, but the Industrial Revolution certainly didn't slow it down either. Deforestation, along with other factors such as overgrazing, droughts, and loss of vegetation, also leads to desertification. An arid desert can't sustain much life without massive inputs of water from somewhere else. Bad land use practices also lead to soil erosion and soil degradation. They are another harmful way to lose even more food security or desertify wild lands. They can also make the earth lose actual land, when the soil that lost its plant life which normally binds it together is swept into the oceans by the rain, rivers and tides. As we take up more and more land, acidify the ocean and heat up the entire globe, everything living here feels the impact. Next boundary already past us is the loss of biosphere integrity, which is the loss of biodiversity in a given area. It tends to happen a lot because we take all the land we find useful to ourselves. And even the rest of the land along with the oceans we use as we see fit, overexploiting natural resources and polluting with chemicals, noise, light and trash. Wild mammals only account of 2 to 4% of all the mammal biomass. Humans account for about a third, and our livestock makes up the large majority of it. Over 70% of all bird biomass is made up of chickens. To feed the growing mass of humans and livestock, we have to exploit the natural resources, such as fish, to a worse and worse situation. As a result, the world's oceans and seas are dangerously overfished. Up to 90% of all the fish stocks in the world are classified as maximally fished, overfished, or collapsed. A study estimated that if we keep fishing at this rate, by 2048, humanity won't get any more seafood for dinner. Unlike the saying goes, there aren't plenty of fish in the sea anymore. Extinctions happen naturally, and they aren't even too rare. But what is rare is the rate that we are losing species. Estimations put the current extinction rate at 100 to 1000 times faster than usual. There really won't be much wilderness or wild animals left if humanity doesn't change its ways. Next boundary on our list is chemical pollution. There are thousands and thousands of different unstudied chemicals which impact us and our environment, and every day more are being developed. There are so many pollutants in the world that it is already affecting us. Reducing our fertility rates is the most significant issue. Because the long-term effects of these chemicals can't really be studied on a feasible timescale to not harm business interests, we simply release them without the necessary studies. Things like microplastics, chemical runoff from industry, consumer chemicals, drugs, and things like the so-called forever chemicals, PFAS, are all hazardous to the environment and us. We don't really know where the safe limits for any of these are. We don't even know much about what they affect and how. Humanity generates a whopping 400 million metric tons of hazardous waste every year. So far, chemical spills and accidents have been the main cause of concern for us. The Bhopal disaster in India was a chemical accident that led to the death of over 2,000 people and over 500,000 injuries. Right now, we are trying to saturate the whole globe into a chemical disaster of unseen proportion. Another boundary we have crossed is freshwater use. Only 0.014%, a minuscule portion of all water, is easily available freshwater such as lakes, rivers and groundwater. All life on Earth depends on water. The ocean encroaching into estuaries or groundwater can turn freshwater salty. Chemical and biological pollution can also ruin otherwise good water. Deforestation, climate change, and the overuse of groundwater are also destabilizing the water cycle, where water first evaporates from masses of water because of sun's heat and then rains somewhere else. The consistent availability of fresh water, as well as the food that's grown with it, allows human civilizations to stay sedentary. Just like all other life on Earth, we cannot survive without fresh water. Agriculture uses 70% of all the fresh water that's being used on Earth. Formerly mighty rivers, such as the Colorado, are drunk up by the fields that are used to grow cattle feed. Today, the regions where the river used to flow into the sea thunderously now only receive a small trickle of water if they're lucky. Most years, the Colorado River doesn't flow into the sea. The Aral Sea in Central Asia was dried up because the Soviet Union diverted the rivers that fed it to instead feed their cotton fields. The Gulf of California isn't drying up, but it is causing untold damage to the ecosystem of the delta, and the river's salinity and sediment deposition problems have caused billions of dollars worth of damage already. The last planetary boundary on the list is actually two, the double boundary of the nitrogen and phosphorus cycles. Both of these elements are vital to life. Nitrogen is found in all amino acids and proteins. Phosphorus instead is needed in the functioning of DNA as well as RNA. Both nitrogen and phosphorus are used as fertilizers in agriculture. But besides their life-giving side, these fertilizers have another side too. As they drain from land to water, the enrichment causes algae blooms, which desaturates the water's oxygen levels, and that in turn causes biodiversity loss, as most life can't handle those conditions. On land too, nitrogen and phosphorus enriched soil causes shifts in the balance of life. Some species adapt to it better than others, leading to the better suited ones dominating. There are differences too between the two elements. Some nitrogen compounds are strong greenhouse gases, which causes yet again more global warming. Phosphorus instead doesn't really leave the ground, but unlike nitrogen, it is a depletable resource that needs to be extracted from the ground. That means while some parts of the world are enriched with too much phosphorus, others are left without enough, so not much life at all can support itself there. All of these planetary thresholds have more causes and effects. This is just a very short introduction to them. And there are more proposed boundaries that haven't been as readily accepted as these 9, at least not yet. But of the 9 of the agreed upon planetary boundaries, we have already crossed 6, and we are heading even further and further in the race to go off the deep end. Only one, the ozone layer, is showing signs of improvement, and that could reverse itself with any new chemical invention. So the world is about to get very uncertain for all of us. How uncertain do we want it to get? Is it ever enough for us?